Hey, students, welcome. It's Friday. It's 4:16. This is our first day of live Zoom classes on Friday. Um, Today's lesson was a little slow, so I wanted to make sure I walk through each of the problems again so you got a chance to watch it, okay? So that do first that we went through today, describe everything you know about the parabola here. Take a moment and just double check what do you know, and then come on back. All right, so pause that. All right. Here's some of the things that we really know about this, right? The h value is 8, right? X minus 8 gives us an h value of positive 8. The plus 2 here gives us a k value of 2, and that means the vertex is 8, comma 2. This a value is negative 1, right? And so we know that the quadratic's going to open down because it is a negative a value. So if we're going to graph that, we come down here and there's a chart table here. Thanks to Miss Miller for getting that table in for us to help graph. We know that 8 gives us 2. So if I go over 8, I go up 2, and I know it's going to open down. Let's plug in this point right here. If this is 8, this is 7. So let's plug in 7 and see what we get. All right. So if I plug in 7, and I did this in my head before, but let's see if I can. Let's grab this equation and do this on paper here. All right, so if I have this equation, I'm going to plug in 7. So if x equals 7, right, we get y equals negative 1 times 7 minus 8 squared plus 2. 7 minus 8 is negative 1. Order of operations says I do my exponents next. So negative 1 squared is positive 1. Now I have multiplication that I do before addition. So I get negative 1 plus 2. And I get the value y is 1. So if I plug in a 7, I get back a 1. So let's put that in here into our graph. 7 gives us a 1, and we can graph this over 7 up 1. Now what's super cool about quadratics, right, is I know this is my vertex, so I know this is my axis of symmetry right here. And so I know that if it's 7, 1, it's also going to be 9, 1, because they're symmetrical, right? This is where we stress this on our last assessment. Okay, 8 gives me 2. On either side of that, I get back 1. So now we need to test 6. So let's go back to our problem. And let's test 6. So if x equals 6, go ahead and try this out on your own and then come back. We get negative 1 is 6 minus 8 squared plus 2. Again, pause this and try it out. See, we plugged in the 6. Negative 1 times negative 2 squared. 6 minus 8, it's negative 2. Then we do our exponent. We get negative 1. Negative 2 times negative 2 is 4. Multiply negative 1 times 4 is negative 4 plus 2. We get a negative 2 when we plug in 6. And so right here, we're going to get negative 2. And now we can always say that 10 is going to give us a negative 2 because of the symmetry. And so we go to 6 down negative 2, over to 10 down to negative 2. We're going to sketch this the best we can on the computer with my mouse. And there we go. We have graphed a quadratic from vertex form. Huge skill today. All right. Good job. All right. So here's your goal and agenda. If you have anything you'd like to share with your teacher, go ahead and type that in there. All right. And we're going to start by creating a quadratic story. So a quick review. Click on these points to find what they could be and fill them in. All right. Come on back when you're ready. Still recording. All right, so how did you do? Did you get all the green check marks? You know, make sure you, even though it has a decimal, it's easy to type in there as an ordered pair. And remember, this value, our x value, or the h value in our vertice, is the same as our axis of symmetry. Hopefully you're seeing that. So now imagine a story, right? I want you to think through a story that talks about you starting here, maybe shooting a basketball, throwing a baseball, or flying a kite and it falls, anything that you can think through to come up with a fun story, and type it here. And I'm going to just say mine out loud to you once you have that done. All right, what kind of story did you come up with? Here's mine. I'm starting right here. My arm's about 3 feet off the ground, and I'm going to throw a baseball just nice and easy up in the air, a nice fly ball for my son to catch. And so I throw it up in the air. At 1.4 seconds, the ball is 12.8 feet high. So just kind of a little bit higher than a basketball hoop. It reaches there and then it comes right down. He misses the catch and it lands on the ground 3 feet away from me. So you can imagine I threw it right up and it came down 3 feet away from me and landed on the ground. Quick little story, but kind of showing that you understand the maximum height, the time it happens, and then when it hits the ground 3 seconds later. All right? Hopefully that makes sense. Go ahead and answer this question. Who's correct? So there's two students here. Jesse, and we're talking about this red quadratic right here, the red parabola. Jesse thinks the equation should be this. Mark thinks the equation should be this. Tell me down here, who do you think is correct and why? All right, give that a shot. So who do you think it was? Well, to go this way in the quadratic, you need to have x minus 3 squared. All right, and so your equation should be y equals 2 times x minus 3 squared plus 1. So who is that? Mark is correct. Now, to get that blue equation, though, to go to the left 3, on the inside of this binomial, right, it's going to be x plus 3 squared plus 1. So that's the big difference here. To go to the left, we have plus 3. To go to the right, we have minus 3. All right, they both are identical except for that plus 3 or the minus 3. Write this in your notes, right? That the minus 3 moves it to the right 3 and the plus 3 moves it to the left 3. That plus 1 on the outside does the same thing to both of these, moving it up 1 in the y axis. So this is a great realization. 3 to the right, minus 3. 3 to the left, plus 3. This is going to come up multiple times. All right. Looking at question 5 now. There's two things here. What's one advantage of the vertex form? And then what's one thing that the standard form and the vertex form have in common? So pause, try those two questions out, and then come back for that answer. All right, so you tried it out? Good, then let's look at it. So one advantage the vertex form has is you can find the vertex, right? That's why we call it the vertex form. The vertex is right in there. That HK value shows up, right? HK, all right? And then since we know what H is, we can find the axis of symmetry just by saying X equals H, right? So write that in your notes. Axis of symmetry, X equals H. All right. And so then what's something both of them have in common? Both forms have an A value. All right. So that A value allows us to know if it opens up or opens down and if it's wide or narrow. Right. Bigger than 1, it keeps getting narrower and narrower and narrower. Between 0 and 1, it's going to be like a big bowl. Okay. Perfect. All right. So now we have a few more. Let's see, 1, 2, 3, 4. 1, 2, 3 problems and then a couple of challenges here. So take a look here, a quadratic tent. Same idea. Fill these out by using the values on this table. And then, do you know what it means? Right? Do you know the maximum height, the width? And if the A value is -2, can you write the equation in vertex form? Try that out. Come on back for the answer. But if you don't try it out, you're never going to know if you could do it on your own. All right, so here we go. You should have already been able to check to see if these are correct. Right? If you click try it, you should get all green check marks. This is 4, 8. That's our vertex. All right, so the axis of symmetry goes right through that 4. Think about this. I forgot to explain, right? If we sliced a tent in half, this would be the cross section of that tent. And so the y-intercept and one of the x-intercepts, the 0 is the same, 0, 0, and then over here at 8, 0. So then, how tall is the tent? Well, if 4 is the width, right, if we go over 4, up 8, our maximum height is 8 feet. And then if we go between 0 feet and 8 feet, right, 0 to 8, our width is also 8 feet. And so if we know that the a value is -2, you should have come up with the equation. Let's see, scroll down. Y equals -2. That makes it open down, times the quantity x minus 4 to the second power plus 8. Any questions? All right. All right, this one's a good one. Think about the things that you need to know here, right? I can already say, well, this is the vertex, here's some x-intercepts, and here's the y-intercept down here. So then go ahead and answer these 4 questions and come back and get your answers, okay? Ready, set, go. All right, hopefully you're able to solve this on your own and at least give it a shot. If you didn't, pause it and really try it out, because that's how you're going to grow. All right, if we're trying to maximize profits here, right, this value down here is how much they charge for the toy. And so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, $13. So if you charged $6, you reach this maximum profit, and it looks like it's about $100 and maybe $60 or so. Again, doesn't matter, but you can, what exactly it is, but you know it's $6. If you charge $6, you make a profit about $160. Okay? Now, and that's what I wrote right down here, $6. So what does the y-intercept mean in the context? Well, if this is $0 charged, that's like giving the toy away for free, right? You would lose $192.50. Right? There's no profit, it's a loss. And that makes sense, right? If you give something away that you make, there's still a charge for it. It still costs you something. And so, in fact, you don't start making money until you hit $2. And then from $2 to $10, you make different amounts of profit, with the most profit here. So then the next question says, well, how do I make $137? Okay, if I want my profits to be exactly $137, right, I'm looking for 137 is just right under this. And so I come right about here and right about here. And so I'm going to estimate that that's $4.50, or since this is symmetrical, it's going to be about $7.50. So either one of those gives us back the same profit, right? Either side of the vertex. All right, and then finally a friend says what? A friend says he thinks that selling it for a higher price results in the highest profit. What do you think? No, we already know that $6 gives us the highest profit. Anything more is going to give us less profits. And in fact, if we charge more than $10, all of this represents losing money. Nobody's going to buy it for more than $10 apparently, or not very many people. Right? It must be one of them cheap toys. All right. Here you get another chance. So Andy's going to throw a baseball that looks like this. So he's starting from 80 and working his way up. Ryu has a chart that represents his baseball throw. So compare those two and see if you can answer these 4 questions. Come back. So there's a lot of information here, right? And so let's digest this. Here Andy starts throwing the ball from 80 feet and he throws it up to about 90 feet maximum, and then it comes down and hits just before 3.5 seconds. Throws the ball, 3.5 seconds later it lands on the ground, or just about. Ryu starts 86 feet up, so if he was on this same scale here, right, he'd be 86 feet up. His ball reaches 102 feet and then comes down just after 3.5 seconds. So if I was to just sketch this quickly right here, here's Andy's graph. Ryu's graph, right, would be about right here, go a little bit higher, and then land just a little bit after 3.5. Again, you can sketch that to do that same information. So here's the answers. Whose baseball reached the greatest height? Well, Ryu hit 102 feet. Andy's baseball maxed out at 95 feet. Whose baseball reached the ground first? We said Ryu's hit at 3.5 seconds, or 3.52, it hit 0. Andy's hit just before 3.5.